Hello, sixth graders. I'm here checking in with Chapter 6, Lesson 5, and today we're learning about the commutative and associative property. I don't expect you to know what those are, though you have either directly, meaning someone's told you those words before, or indirectly, meaning you've been working on the concepts without knowing the name for them for a long time, okay? For right now, first thing I want you to know is look, the word commutative has the word commute as a base, okay, or as a root. And associative has the word associate in it, okay? That will help you pronounce them and read them, okay? So what are we learning? We're going to learn that commutative means that if you're multiplying or adding, if it's all multiplication or all addition, it doesn't matter what order you add the numbers in. Okay, and we'll talk more about that in a second. And with associative, if you have all multiplication or all addition, it doesn't matter how you group the numbers. Okay, so get out your math notes because I'm going to talk to you about these properties in more detail and you need to take notes. Remember, you can use your notes on the test, and you need to be able to refer to this throughout the lesson. So I don't want it on a page that might get lost or thrown away. All right, so I'm turning to the next page here, where they have some notes for you, but I'm going to talk to you about them in a way that has helped students before as well. Okay, so at the top of your paper, put a title that says commutative property. This right here, commutative properties, make that a title. Then I want you to draw my picture of the school bus going back and forth between school and home. Okay, so see this is the road with an arrow, and same road with an arrow. Notice the arrows are in opposite ways. Okay, so what's the big deal here? Our drive to school or work or someplace that we go every day can be referred to as our commute. Adults will talk about that. How far is your commute? We talk about that here at school because some of us come from Lake Tahoe, some of us come from Gardnerville. So our commutes are very different, right? But no matter how far each of our commutes are, if I drive 15 miles to get to work, it's also going to be 15 miles to get home. So even though my commute was in an opposite direction, it was the same amount of miles. Okay, so look at this right here. This is what you've been doing for a long time. 7 plus 9 gets 16. The same as 9 plus 7 is 16. Okay, you will see us write that as A plus B is the same as B plus A. All right, that's the same as writing this here. 1 plus 2 equals 3, just like 2 plus 1 equals 3, right? Same thing with multiplication. 4 times 6 and 6 times 4 get the exact same product. We write that as A times B is equal to B times A, okay? So I want you to write commutative property, draw the picture of the school. Underneath that, write these examples, and off to the side, I want you to write grouping, really big, grouping, and underline it, okay? Because commutative I can't believe I just did that. Don't write that. This is Munyon. Okay. If I had time, I'd remake this video, but I don't. Okay. And then I'm going to write again. Grouping is associative property. You need to write order. It doesn't matter what order you work out a problem that is all addition or all multiplication. It's going to be the same. Okay? Order. Write order. And I'm sorry if you already started writing that, but hopefully you were still drawing your picture. Okay? After you finish that, you need to make another big title and write associative property. I should say underline the root word commute in commutative, and then an associative, underline the root word associate. Okay? So this is a lot of notes. It's very important notes. And I'm hoping that everyone's listening and not just watching and actually doing this. If you show me your notes when you're done, I will give you some hawk feathers because it is a lot of notes. Okay? For associative property, and please make sure you're pausing this because I'm saying a lot and you need to write it all. I want you to write this. I always think of girls for associative property, but it's guys too, okay? So, Cedar and Ayana and Raylan are all friends, okay? Maybe one day at recess, Cedar and Ayana play together. Maybe they're doing beading that day, okay? Oh, I'm going to have to make this smaller. It's okay if you wrote it. It's not going to change, okay? But I do need to make it smaller. Cedar and Ayana and Raylan are all friends. One day, Cedar and Ayana are playing together, but they're still friends with Raylan, okay? And the same on the other side, okay? Cedar and Ayana and Raylan are all friends, but maybe on another day, Ayana and Raylan are playing together, but Cedar's still their friend. They're all friends. In the end, they're all friends, okay? But they might play with different people on different days, and that's all about grouping, okay? Associative property off on the side, right? Grouping. Still can't believe I got this written incorrectly. And then you need to write down all of these examples. Notice same numbers, 3, 9, 4, 3, 9, 4, and all addition. Okay? So in the first one, they grouped 9 plus 4, meaning according to PEMDAS, we're going to add 9 plus 4 first. In the second one, they grouped 3 plus 9. Okay? They'll get the same answer unless they make a mistake. In math terms, when we talk about associative property, you will see this, though. A plus the quantity of B plus C is the same as the quantity of A plus B plus C. Okay? All right? It works the same in multiplication. Notice same numbers, 8, 5, 7. 8, 5, 7. They just grouped them differently. Here they're multiplying 5 times 7 first, and here they're multiplying 8 times 5 first. And the way we write that in math, A times the quantity of B times C is equal to multiplying C by the quantity of A times B. Okay? Same. All right? So once you get all that done, you have one more title to write. You need to write the identity properties. Okay, and off to the side, I want you to write, you can't change me. That sounds a little sassy, doesn't it? But it's true when it comes to the identity property and to some basic things about yourself. You can change you, but there are certain aspects of you that people need to just value and respect, such as your ethnicity. Even you cannot change that. You cannot change who you were born to. Okay? You cannot change the culture you were raised in. And hopefully that's something that you value and that other people value about you as well. But even if they don't, they can't change you, nor do they have any right to. Okay? So, identity property. If we add 0 to a number, it doesn't change that number, does it? 13 plus 0 is still 13. If I have 2 cookies and I give none away, I still have 2 cookies. In math, we write A plus 0 equals A. Write both of these lined up just like this underneath your title. Okay? Same with multiplication. If we multiply a number by 1, it's still that number. Okay? 7 times 1 is 7. 5 million times 1 is 5 million. A times 1 is A, okay? Make sure you write down both of these examples. So when we say this the long way for each of these, we'd say the identity property of multiplication, the identity property of addition, and same with the other two as well. Okay? All of that needs to be in your notes. If it takes more than one page, that's fine. Okay? Make sure it's there. You will be referring to this throughout this chapter, and you will need to understand these concepts throughout life. And just so you know, if you're thinking, oh, I'm going to learn the concept but not the words, you will see it again in middle school. You will see it again in high school. You will see it again in college. So do yourself a favor and just know the words as well. Okay? Let's go back to the first page. All right, I have some reading to do here. Angelica and Nari are baking cookies for a bake sale fundraiser. Angelica baked 6 sheets with 10 cookies each, and Nari baked 10 sheets with 6 cookies each. So I'm going to underline some key details here. Angelica, 6 sheets with 10 cookies each, and Nari, 10 sheets with 6 cookies each. All right. So how many cookies can Angelica bake? So Angelica had the 6 sheets, 10 cookies each. What should we do? Add, subtract, multiply, or divide? Yeah, we need to multiply. And what would that be? That would be 60 cookies. 60 cookies in all, if she had 10 cookies on each of her 6 sheets. And Nari, she had 10 sheets, 6 cookies each, so we'll multiply. Oh, also 60 cookies. Okay? So she had less cookies per sheet, but more sheets. So she ended up baking the same amount of cookies. That's really good to know in baking, right? So in a huge bakery, you have lots of baking sheets, but maybe in your home, you only have so many and they're a certain size. So you need to find multiples of that to figure out how you're going to bake all your cookies, right? So what do we notice about these? Okay, they have the same product. Okay, and since we already skipped ahead and found out about our properties, what property is that? Did they group these numbers differently, or did they move the numbers? Did they change the order? They changed the order, right? They changed the order, so this is commutative property. Commutative property. So what do these exercises suggest about the order in which factors are multiplied? We can multiply in any order. We can multiply in any order, so long as what? It's all multiplication, right? Because as soon as we add another operation, add, subtract, or divide, then we need to follow order of operations, PEMDAS. Moving on. Okay, we already looked at this part. I did not read this to you, so I'll do that really quick. Properties are statements that are true for any number. The expressions 6 times 10 and 10 times 6 are called equivalent expressions because they have the same value, okay? This particular example here of equivalent expressions demonstrates or illustrates the commutative property because they change the order. Let's look at some examples. Determine whether the two expressions are equivalent. If so, tell what property is applied. If not, explain why. So we have 15, 5, 8 and 15, 5, 8. It's all addition. So I'm not even going to add. Same numbers, all addition. The order they're added does not matter. These expressions are equivalent and they used grouping, right? So that is associative property. Okay, now let's look at these. 20, 12, 3, 20, 12, 3. It is not addition though, so I'm going to slow down and think about this. Up above, we did not define associative property as applying to subtraction. So let's just work it out. Here we have 20 times 12. 20 minus 12, that's 8. And if we subtract 3 more, we get 5. And here we have 12 minus 3, that's 9. And if we subtract that from 20, that would be 11. Oh, not equivalent. Not equivalent. Associative property does not work for subtraction. Good to know. Okay. Determine whether the two expressions are equivalent. If so, tell what property it is applied. Oh, 34 plus 0 in 34. Well, if you add 0 to 34, it's not going to change it, right? And this one is 34, so 34 plus 0 is equal to 34. What property? Identity. You can't change my identity. Okay? 20 divided by 5. 5 divided by 20. So here we reversed order. That's commutative property, except commutative property only works for multiplication and addition. It didn't say it worked for division. And if we were to work these out, 20 divided by 5 is 4, and 5 divided by 20 would be a decimal. So these are not, oops, sorry about that. These are not. My pin stopped working. That is not going to work. Let me try putting it in and reconnecting it. Not equivalent, right? Oh, I'm worried. Okay, so I'm going to pause the video. All right, so here we have, we just need to solve them. It's not asking us to say what property it is. This is do the problems to find out. Do we really have to, guys? Look, 5, 6, 3, 5, 6, 3. Same numbers, all multiplication. We already know it's going to be equal. Could we solve them to prove we're right? Of course we could. 6 times 3 is 18. Multiply that by 5. 5 times 8 is 40. 5 times 1 is 5, plus the 4 is 9. So that side is 90. 6 times 5 is 30. Then times the 3. 3 times 3 is 9. 1, 0. There you go. What about this one? So I see commutative property. They switch the order of 27 and 3, but it's division. Commutative property does not apply to division. Okay, so I already know they are not equal. Okay, but let's prove it. 27 divided by 3 is 9, and 3 divided by 27, that would look like this. So we'd have to add a decimal. This is not equal. This one will be less than 1. It's a decimal. Okay, moving on. In a recent season, the Kansas Jayhawks had 15 guards, 4 forwards, and 3 centers on their roster. Write 2 equivalent expressions using the associative property that can be used to find the total number of players on their roster. And they did it for you. First, they added the 15 guards, and then they used associative property to group together the 4 forwards and 3 centers. Here, they grouped 15 and 4, and then added the 3 centers. Easy. Why would we want to know that anyway? Well, it's not so obvious in that particular problem. But what if your problem was 9 plus 4 plus 1? No, 7. I'm going to change that up a little bit because it's super obvious there, right? What if it were 23 plus 4 plus 7? Well, if I use commutative property and move the numbers around, plus 7 plus 4, anyone see it yet? An associative property to group 23 and 7. What do I know about 3 plus 7? It equals 10, right? So 23 plus 7 will equal 30, and then 4 Wasn't that easier than if I'd added 23 plus 4 and got 27 and then needed to add 7 more? Much easier to work out in my mind, okay? That's why we need commutative and associative property, because we can rearrange to make it easy addition, okay? Looking at C, financial literacy, Brandy earned $7 for babysitting and $12 for cleaning out the garage. I'm going to underline those. Earned 7 for babysitting and 12 for cleaning out the garage. Write two equivalent expressions using the commutative property that can be used to find the total. So we could write 7 plus 12, or we could write 12 plus 7. That's like driving home versus driving to school. It's the same amount of miles. All right, moving on. Number 6. The area of a triangle can be found using the expression 1/2 times base times height, where b is the base, h is the height. Find the area of the triangle shown at the left. Oh, I can't see it. Here we go. So we have our height and we have our base, and we know that it's 1/2 times 15 times 12. Look here, this is the part I want you to notice. They used commutative property to reverse the order of the 15 and the 12. Why would they do that? Because then we can cross cancel. 2 and 12 are both divisible by 2. 2 divided by 2 is 1. 12 divided by 2 is 6. And that means we're really just doing 6 times 15. Isn't that easier than trying to multiply 15 times 12 and then have to divide that by 2? Yes, definitely. Let's look at D. Vicky earned $6 an hour while working 11 hours over the weekend. She put 1/3 of what she earned in a savings account. Okay, find out how much she put into the account. So we know we have $6 times 11 hours, and then basically we divide that by 3. We write it as times 1/3. I'm seeing that if I use commutative property to switch these two numbers, then I can divide 6 by 3. Watch. 11 times 6 times 1/3. Remember, whole numbers can be put over 1. Okay? And 6 and 3 are both divisible by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So what's left? For my denominators down here, I only have 1s. So basically nothing, because if you divide by 1, you're going to get that number. So what is left for numerators? All that's left is 11 times 2. Okay? So my problem has become, I need a marker here. 11 times 2, which is $22 that she has saved. $22 saved. Cool. All right, let's try these. Determine whether the two expressions are equivalent. If so, what property is applied? If not, explain why. Okay, so we have 35, 17, 43, 35, 17, 43. Same numbers, all addition. They are equivalent. What property? They're in the same order. Here, 35 and 17 are grouped. Here, 17 and 43 are grouped. So this is associative. Okay, let's look at the next one. 25, 9, 5, 29, 5, 9, 5. Same numbers, but look here. That is subtraction. Our new properties or rules that we've learned don't involve subtraction. So these are not equal. Why? Okay, our properties, no subtraction in our properties. Okay, next one, 59 times 1 and 59. Well, 59 times 1 is 59. So these are equivalent. And what property? You can't change me. That's identity property. Identity. At a gymnastics meet, a gymnast scored 8 and 95 hundredths on vault and 9 and 2/10ths on the uneven bars. Write two equivalent expressions that could be used to find her total score. Oh, it doesn't ask us to solve. Woo, happy day. So we have 8 and 95 hundredths. We need total score. That means we're adding plus 9 and 2/10ths. And that would be equal to, let's use commutative, right? 9 and 2/10ths plus 8 and 95 hundredths. Cool. Then Nadia bought suntan lotion for $12, sunglasses for $15, and a towel for $18. Use the associative property to mentally find the total of her purchase. All right, associative property. So we have 12. It says total, so we're adding plus 15 plus 18. And we're going to use associative property. So what might I prefer to group? Actually, we're going to need to use associative and commutative, I think, because I see that 2 plus 8 is 10. So I'm going to use commutative property to, maybe these were grouped to begin with. So I'm going to move the 18 close to the 12. So I'll do 12 plus 18 and group those for associative property. Then I'll add the 15 last. How does that make my life easier? Well, because I know 2 and 8 is 10. So that's 10, 20, and my 10 from the ones, 30 plus 15. How do you think of 30 plus 15? I break the 15 up into 10 plus 5. And now I can do 30 plus 10, which is 40 plus 5 is 45. Equals 45. $45 spent on all of our things for the beach. All right. How can using properties help you to simplify expressions? Well, we had a couple examples here, right? We had this one where we use commutative and associative to make it easy mental math. And then we had the one I wrote out. Oh, we did that here too, so that we could cross-cancel easily. And then we had, where's that other example? Oh, up here, where we used commutative and associative property because we knew 3 plus 7 was 10, is 10. And that made it easy to do mental math there. Okay, so regrouping or moving numbers. Regrouping or moving numbers in an addition or multiplication problem makes mental math easier, right? Makes mental math easier. Yay! Work smarter, work harder, right, guys? So now I want to point out to you that even though we're learning strategies that could potentially make easy mental math, I expect you to show a little bit of your logic. You don't have to write everything out, but I want to see some steps just like I did here. Could I have done all of that in my head? Yes, I could have. But what if I made a computation error? Or what if you did? I could look at your work and go, okay, I see the strategy they were using. The strategy is correct. They made a brain typo, okay? And really, I'm looking to see if you can use strategies for commutative, associative, and identity property. So show me some work, enough that I can see what you did in your head. All right, bye, guys.